Now what is interesting for us to do is to use this swap example, okay, the good version of swap and the bad version of swap, and to go back to our stack diagrams and see exactly what's happening at a lower level, okay, to just pretty much explain, justify all those rules that we have been observing. So I'm going to start with a basic stack diagram. Okay, there you go. Text segment is somewhere here, data BSS somewhere here. We don't really care about those right now. This is the activation record of the main function. Contains a variable x, contains a variable y of type integer. Okay. Before to actually show the stack diagram corresponding to this version of the code, I'm going to pretty much go back to the previous version, the one that was not working, the one where the parameters of the swap function were just int1 and int2. Okay, and I'm going to show you what happened. And then we're going to compare this, make a diagram next to it, showing what happened with this version of the code, which is using pointers. So we have x and y, okay? X was set to 42, y to 99, sorry. We do our first printf, okay, it goes on the screen 42 and 99. We call swap, and like I said, I'm going to use the old version right now for the sake of this explanation, so keep in mind, okay, what I'm drawing the diagram of right now is calling swap x and y, okay, and so that means that, well, actually I'm going to keep the code modified so that you have on your screen next to the diagram the old version. That will probably spare us a couple of confusion, and then I will modify it again and we'll trace the new version. Okay, so everywhere I'm removing pretty much references to the pointers I introduced. Okay, I'm reverting back to the first version of the swap function, the one which didn't work. Okay, so a couple of stars need to disappear here again, and we are almost done with these ones. Okay, let me check that I didn't introduce syntactical error, so far so good. I run it again to make sure, and it's not working. Okay, that's what we expected. So let's go back to our stack diagram, and now we're going to take this code, the code which doesn't work, and we are going to draw the stack diagram of what happens exactly. Okay, so I'm here, I'm calling swap xy. When I do so, this was the activation record for the main. Okay, I create a new activation record for this invocation of the swap function, so some system information here. What do I find in the swap function? I find two parameters, 1 and 2. So these go on the stack. I find local variable tmp. Okay, the three of them are int variable. So 1 and 2 receive a copy of the values in x and y, okay, because I'm passing x and y here as parameters. So 42, 99 are copied. TMP for now as, I don't know, okay, undetermined. I'm going to scroll down a bit, and I'm going to run step by step what I'm doing here, which is display on the screen the value of 1 and 2, 42, 99. Then TMP is assigned the value inside of 1, so TMP is now 42. Okay, 1 is assigned whatever value is in 2, so 1 now contains 99, and you see how we are modifying, of course, the local variables specific to this invocation of the swap function. Okay, 2 is equal to TMP, so 2 receives the value 42. We display again 1 and 2, bingo, they have been permutated. Then we return from our function. Okay, this activation record here goes off the stack, and we are back in the main where, of course, nothing changed. Okay, so that was our first version of the function, the one which didn't quite, do what we wanted. So I'm going to reapply the modification that we already discussed. So I'm transforming 1 and 2 into pointers, so that instead of passing the value inside of the variable x and y, I can pass the address of those variables to my function. Of course, the parameters in the definition need to match the declaration in the function prototype, and I will reintroduce pretty much all the syntactical modification that allow me to use 1 and 2 as pointers on integer variable as opposed to integer variable. So that means introducing dereference operators everywhere. Okay, as usual, we are, before to keep talking about this program, we're going to make sure that it's syntactically correct, all right, and that it's doing what we expect it to do, which is permutation of x and y. Okay, we're in good shape. Now, let's take a look again at this code. we're going to start here. Alright, beginning of the main, and let's draw the stack diagram corresponding to what happened when I run this code. So x and y are local variables in the main, value 42 and 99 respectively. I display them on the screen. Okay, now I'm here. Invocation of the swap function. So new activation record, okay. Some system information is pushed onto the stack. This is activation record corresponding to this invocation of the swap function. I pass address of x and address of y. Okay, these are going to be fed, between quotes, to parameter 1 and 2. So we are not going to pass the values of x and y, 42, 99, okay? What we are passing is, let's say that variable x is at a memory address which we are going to call alpha. Variable b is located at a memory address which we call beta. Okay, the address of x is an expression, okay? The address operator is applied to the variable x, which results in a value which is the address at which variable x is located. Let's call it alpha. And same thing for 2. So this is what we are passing. We are passing values, okay? But we are passing values which are not the value inside the variable x and y, but the address of x and y, which is going to allow us to access them remotely, okay? So in this case, you would say that 1 is pointing to variable x, 2 is pointing to variable y, okay? And again, being able to make that kind of stack diagram is really useful not only in understanding what's going on, but also when the time comes, debugging problems that you have with this kind of program. The local variable TMP, okay. TMP is assigned *1, so I take 1, I dereference to the address contained in the variable 1. I'm now on x, okay? So TMP is equal pretty much x. That's 42. *1, so again, a dereference from 1, I'm now on x here, is assigned *2. So I take 2, I go at the address contained in variable 2, okay, I dereference, I'm now on y. So pretty much I'm doing x equal y. So x receives the value contained in y. And this is, of course, the whole difference. That is that through 1 and 2, we are now modifying remotely the variable x and y, which are in the activation record of the main. Okay. Last line, dereference to the address contained in variable 2, and assign TMP to whatever is there. So here we go, 2, I dereference, I'm on y. I assign whatever I have in TMP, which is 42. And that shows clearly how this version of the code actually is doing the job that I intended, because once I return from this function, okay, the activation record corresponding to that invocation of the function disappears. All those pointers are gone, but I did exactly what I was tasked to do, which is modifying variable x and y, and that's why the display is correct in this case.